Hi everyone, in this video you have to find this limit using three different ways. So the first method, you have to use the definition of the derivative, which is in part A. So as you know, f prime of x equals to limit f of x plus h minus f of x divided by h when h goes to 0. So you have to modify this limit and rewrite it, arrange this limit to get the formula of the definition of the derivative. So we can write the limit as limit, take negative from numerator as greatest common factor, and you will get cosine pi over 3 plus h minus 1 over 2 divided by h when h goes to 0. Now the second step, you have to rewrite 1 over 2 as cosine something, and you know that cosine pi over 3 equals 1 over 2, so we can write 1 over 2 as cosine pi over 3. Now by compare our limit with definition of derivative, you will get that the function is cosine x and a equals to pi over 3. So our limit equals to what? Equals minus f prime of pi over 3. So the first derivative, f prime of x, equals to negative sine x. Then you have to replace pi over 3. F prime of pi over 3 equals to negative sine pi over 3. And as you know, sine pi over 3 equals square root of 3 divided by 2. So f prime at x equals pi over 3 is negative square root of 3 divided by 2. So our limit will be negative f prime of pi over 3, so it will be minus square root of 3 over 2, and the answer will be square root of 3 divided by 2. This is the first method using the definition of the derivative. The second way, in part B, you have to use trigonometric identities to find this limit. So again, our limit is limit 1 over 2 minus cosine pi over 3 plus h divided by h when h goes to 0. And as you know, cosine A plus B equals cosine A cosine B minus sine A sine B, so A equals pi over 3 and B equals to h. So the limit is limit 1 over 2 minus cosine pi over 3 cosine h minus sine pi over 3 sine h divided by h when h goes to 0. Now for numerator, cosine pi over 3 equals to 1 over 2, so we can delete this and put 1 over 2, and also sine pi over 3 equals to square root of 3 divided by 2. So you can take a greatest common factor from numerator, which is 1 over 2 multiplied by limit. We have 1 here, then minus cosine h, then we have minus square root of 3 times sine h divided by h when h goes to 0. Then we have 1 over 2 multiplied by limit. Now we can separate the limit, so we have 1 minus cosine h divided by h when h goes to 0. Then we have plus limit square root of 3 sine h divided by h when h goes to 0. And this is equals 1 over 2. And as you know from previous examples, that the limit of 1 minus cosine h over h equal to 0 by using the conjugate technique. So this limit equals to 0. This is as homework for my student. And we have the second limit, limit square root of 3 sine h over h, and sine h over h equals to 1. Multiplied by radical 3, you will get 0 plus square root of 3, and the answer will be square root of 3 divided by 2. So we have the same answers in the first method and the second method. We have the answer square root of 3 over 2. The third method is to use the Hapita rule. And Hapita rule, you have to check that the direct substitution of our limit is 0 over 0. It is easily to check that. Then you have to find the limit of f prime divided by g prime. So you have to find limit f prime of x divided by g prime of x when x goes to 0. Now pay attention that our variable in the limit is h. So you have to replace x by h because you have to find the first derivative with respect to h, okay, not x. So we have limit, the derivative up is 1 over 2 is a constant, so the derivative is equals to 0. Then we have minus, cosine is negative, so minus minus will be plus, sine pi over 3 plus h. This is the derivative of the numerator, and the derivative of denominator equals to 1 because we have h when h goes to 0. So finally you have to use the direct substitution, and you will get sine pi over 3 plus 0, which is sine pi over 3, and as you know, it is a remarkable angle pi over 3, and sine pi over 3 equals to square root of 3 over 2. And that's it. Thank you.